In this short video, I'm going to show you some of the stack tools that are available in ImageJ to extract quantitative information in Z dimension. The first thing I'm going to show you is simple orthogonal viewer, in case you don't know. It's a useful tool to examine the image. You can replay over time and see how things are changing. Control-Shift-H is the short key for that function. For quantitation, there are a couple of options available. One is plot z-axis profile over time or over z dimension. Let me do the other one as well. Well, the stack must be selected. Oh, sorry, it's image stacks plot z-axis profile over time. If you press live, both of the graphs become interactive. What is plotted here is the mean value of the entire image, which may not be useful, but you can draw an ROI. Then it calculates and plots the z profile of the mean values for this ROI over time or over z positions. And if this is something that you could use or you're interested in, you can extract these graphs by saving them. You can save them as CSV files and then recreate the graphs in Excel or in some other software. But there is another option which is even more useful. But before we do that, let me crop the image because it will be easier to see what's going on. Control-Shift-X crops the image to that ROI. Now this useful tool is under stacks. It's called Reslice. As you can see, we have several options here: top, left, bottom, right. Let's say if we go from top, then the tool is going to go from top to bottom along y axis and create a collection of XZ slices. And similarly, you can create the collection of YZ slices when you go from left to right. Our image is 154 by 194. That's why XZ slices are a little bit shorter and the YZ slices are longer. Now, the software calls this dimension as Z, but it's not Z. In this case, it is actually Y, because it goes from 1 to 194. And if you remember, the dimension of the original cropped image is 194 in Y dimension. And YZ slices go from 1 to 154 because the X dimension is 154 pixels. But now what you have here is the collection of YZ or collection of XZ slices. You can replay it over time. Now you can treat them as separate images, resave them, and do quantitation on them. You can draw, let's say, line and create line profiles at interesting location or time point. But it gets more interesting if you reslice the image along a certain line. Let's say if I draw a line here and execute the same reslice, now it gives me the slice count. There is no direction because it's going to reslice it along this line that I just drew. It's a very tiny stack. So apparently the length of this line was 59 pixels. That's why the XY dimension of this newly created image is 59 by 21, and 21 is the number of stacks in the original image. Now this is Z slices along this line over time, and you can easily make a nice quantitation here because this portion of the membrane, no matter how cells move over time, it's still within the same image. You can follow this easily in a more streamlined manner. You can apply the same plot z-axis profile tool to this newly created image. Now this is the mean value of the entire image. As you can see, it is going up over time. Or you could draw a line or smaller ROI and follow the intensity within that ROI. As I said earlier, you can save this graph, and saving the graph can be done in a different way as well, which is I recommend because it saves the ROIs as well. You can come back later on to it. And that tool is ROI Manager under Analyze Tools, ROI Manager. So let's say this rectangle you can add to the manager, and even if you click elsewhere or go to different images, you can come back and recall that ROI and save it. Let's say if you want to make another different one, you can add that. Now you have 2, or it could be a simple line. You can add that as well. So now we have 3 ROIs. So you can save the collection of ROIs, which I recommend under More, Save. It saves this, and then later on you can recall all of the ROIs that you made measurements on. It's good for referencing, and also making this graph or extracting the quantitative information can be done through the ROI Manager. Once the line or rectangular ROIs are selected, you can go to Multimeasure and perform measurements over time within this ROI. What is measured was set by setting or selecting the measurements here. You can select anything that you want, and when you perform this multi-measure, it's going to perform all of these measurements that are selected here. Now we have only 13 time points, but we have 26 measurements here because this ROI Manager does not separate between channels. What's listed here is the first one is channel 1, channel 2, channel 1, channel 2, so on. You can save this in and separate them in Excel file, or you can split the image and do these measurements for one channel only. Again, this ROI Manager is very handy to save those ROIs. Now if I do this multi-measure, now it's going to give me only 13 slices, so there is no need to separate them later in Excel file. So these are the very useful functionalities built into ImageJ to do measurements with Z-stack data.